through what we have done in the software engineering community in the last sprint, and take a look at the planned activities, and then we talked and do a bit of a Mentimeter exercise on the next steps in the software engineering community. So what we did was that we had this software engineering community is of course a cross-team collaboration. It's as we advocated previously, our goal is to be more focused on programmers, architects, testers, all roles that work with software technology in modern companies, rather than product development or systems engineering. And of course, this was started because we realized that in many reporting workshops, there is a lot of projects that could fit into different teams very easily. And we were interested in what we were doing. So what we did during the last sprint is some of you visited our CI/CD workshop, where we discussed what we are doing in this area. Azim presented some testing effort, some testing tools, and we discussed several problems that I will come back to. We organized a KPI workshop together with Bosch and project number 37, where we discussed a bit more in depth similar issues what Alessandro have shown. And then we organized 3 brown bag seminars. One about software testing, where Azim presented his tool, and one about digital transformation and software sustainability with Patricia Lago and Birgit Penzen-Stadler, and experiences from setting up an effective measurement program in a very short time from Axis, which was presented by Ulla. Which all of these 3 seminars had a very good turn up of participants, around 50 each. So what we discussed in the CI workshop was that we would like to organize a hackathon. We discussed a lot machine learning and continuous integration. We discussed testing periodicity and triggering of testing, continuous deployment, and information needs around testing and CI/CD. The hackathon was actually planned to take part to happen last week, but many of the teams that we were in contact with, they either had competing hackathons or PI plannings or other activities. So we decided that we will try to postpone the hackathon to the spring, and if the situation allows, maybe organize that even physically, because that's much more fun than organizing this virtually. When we talked about machine learning and continuous integration, we have discussed a number of open questions that we should follow. One of those was, for example, the bottlenecks in CI/CD chain. The reason why we write it CI/CD/CD is because we want to stress that it's not only continuous integration, continuous deployment, but also continuous delivery chain. We would like to look a bit more into things that are a bit more specific to what makes CI and CD workflows slow, or what kind of bottlenecks exist, whether that is testing, code reviews, some sort of model analysis, or other type of things. Then we also wanted to discuss how to get hints whether a specific test case will fail. So a very fast ability to orchestrate the test based on previous executions and based on knowledge about the code that is being integrated. We also discussed the challenges that we should address around how large should the CI output be for making a release decisions. So quite often we could see that every time we build a software product, there is a huge amount of static analysis checks and test outputs that are irrelevant. So the question is, how much should we really know about our product before making a release decision? How to use predictive test selection. So if we start selecting test cases based on a prediction whether a test case would fail or not, we have to remember that it's still a prediction. So we select some tests away, and the question is what happens if we are wrong in the predictions. So how do we use predictive test selection in the most effective way? And how do we speed up code reviews? How do we make sure that we don't review too much code and we don't review too little code as well? And also, if we review the code, how do we make sure that the comments that we provide are essentially relevant, which we found could be a challenge in many of the cases. When we talked about test periodicity and test triggers, we discussed a number of open questions. For example, how to gain confidence in release in presence of flaky tests. So how do we know that test cases that the problems that we observe with testing are caused by flaky tests and not by the source code problems? Then, of course, what other solutions to the flakiness of the test cases exist, in addition to removing the test cases? So how do we make sure that we actually do something about them? How to introduce intelligent test case selection and assessment. So a test case, and we have assertions, but the question is, how do we make sure that we also could capture other things in the test cases, not only assert the things that we assert? How to monitor what has changed since the last execution of the test case. That's a challenge because right now we can very easily monitor what has happened between two different builds in terms of changes in the code, in the environment. But if we start orchestrating test cases, and not all test cases are executed on every build, how do we know that what has changed between one test execution and another? And if we broaden that up, how do we know that things outside of the code environment have changed? For example, requirement documents, the deployment hardware, deployment environment, test environment, things that basically are not part of the software product code. And then, of course, how do we use machine learning to trigger the tests? Do we use it to change periodicity of the tests? For example, instead of running every test every time, we run it every other time and then come back to every time, depends on the test case failures. There is a lot of ideas and questions around those topics. When it comes to continuous deployment, we discussed the need to solve the problem with continuous certification. Certain parts of software, when we put them in a product, in order to test them, for example, on public roads, in public networks, we need to have a certification of certain type. How do we make sure that these certification processes do not stop continuous deployments and continuous integration? When we do continuous deployment, how do we know which kind of environments and test strategies work best and when? For example, Dockerization, containers, all kinds of open source environments. How do we know what kind of tool chains work best and when? The challenge with this kind of with having too many tools is, of course, that it requires too much competence, and it's a problem for companies to maintain them in the long run. And when it comes to CI environment, measurement environments, modeling environments, those environments are part of the software development, but they are not part of the software product. So the cost of them should be, or the business case for them should be very easy, and they shouldn't cost too much. Which brings us to the next point, how to reduce the complexity of the environments. If you look at the CI tool chains in different companies, we quickly see that it's often a lot of open source tools, Jenkins, Kubernetes, Grafana, Docker, which have to be maintained both in terms of version control, but also in terms of complexity, knowledge, message buses, and how do we evolve those environments? So what's the minimum complexity that you really need to have in those tools? How to maintain and increase technical sustainability. number of tools, knowledge, understanding, traceability, vendor lockdown, kinds of things that relate to the fact that we cannot be dependent on one technology forever, and we need to be able to move around, evolve, and technology should not be the showstopper for the product development. How do we simplify the CI and CD flow for its users? How do we make sure that all kinds of roles in the company have a very good understanding of these flows? How do we drive the dashboards from that? How do we create drill down tools based on or drill down views based on the generic CI/CD flow? How do we give developers an easier overview of the pipeline, not only for the software development, but all the way to the customer and even back when we get the data from the customer to create new requirements that will go into a specific feature, into specific software release. Right now I would like everyone to go to this website, and I will change the screen. There are a few questions there, so let's see how this works. I'll stop sharing and I will stop